So we've looked at these annuities in a few different directions at this point, but we've all been dealing with what we call ordinary annuities, where you make payments at the end of the month or the end of the year or the end of the what have you. The other main type of annuity we're going to consider is what we call an annuity due. So the only real difference, same format of regular payment, same idea of interest building up on the payments over time. That format is the same. The only difference is instead of making payments at the end of the payment period, you make them back at the beginning. In a nutshell, that ends up meaning everything gets one last period worth of interest building. So it's actually a little bit better off if you could afford to make the payment from the beginning, I suppose. And it ends up adjusting the formula ever so slightly. So the future value of annuity due with a subscripted DUE, hopefully that makes sense, looks really, really similar. So we've still got that guy. Looks exactly the same so far. I said everything gets one more round of interest applied to it. Yeah, we really do just kind of bolt another copy of 1 plus I on the back of our formula. So yeah, it doesn't alter stuff all that much. So let's take a look at an example or two, and by or two I mean exactly two, and then we'll call it a section and take a look at something else going forward. All right, so we're given a payment of $120 being done at the beginning of the month. That's what clues us in. Like I said, if you look for beginning versus end, that's the signifier there. So, and we've got 8 years. So T is 8. We've got an interest rate of 6.3%. As usual, turn that sucker into a decimal. And we're compounding monthly. I think that was already back at the beginning of the month. So yeah. All right. So that's our setup. So we divide 0.063 by 12 to get our periodic rate I. I got 0.00525. So I don't have to round anything off. I'm just going to carry around more decimal places. We have 12 payments per year times 8 years. That's 96 total payments that are being made. So we fill in the blanks. R is 120. So 1 plus I, as is usual, I'm not going to write 1 plus 0 point this thing. You get the idea. Minus 1. I am enclosing that stuff up in the top in parentheses, to help out. I'm really not doing it here because the formulas that appear on your formula sheet won't have those parentheses. So anyway, then we've got this extra guy hanging around on the back. So we have one more copy of 1.00525. I guess you could rearrange if you like, but I think it's cleaner this way. All right, so we don't have any really fancy pants solution stuff we need to do here. It really is just a matter of cranking out all the arithmetic. You might find it beneficial to do all of the stuff in the bracket and then multiply by 120 and then by this guy. So when I work it all out, I get 15,007 dollars and 48 cents for what I'd have in my investment by the time it's all said and done. So there we go. That's cranking out a future value given all of the stuff that we need on the right. So interest rate, number of payments, how often we're making them, that kind of thing. All right, we've got another example that does that sort of sinking fund thing. What if we know we want some money set aside? So let's take a look at that guy. I'm going to go ahead and get rid of my formula here. You've had ample opportunity to write it down or do whatever. So, or point out the relevant spot on the formula sheet, All right. So this time around, we know we want 30,000 bucks set aside. So S is 30,000. Our interest rate is given as 0.07. Compounded annually. Good news. That means it really is our I this time around. And we're told we're going to do this over the course of 6 years. Since it's annual, that's 6 payments. So, all right. So we've got S, we've got I, we've got N. We don't know R. So let's fill in the blanks. So 30,000 equals R. Again, hopefully this bit feels familiar. We have 1.07. It's not 100% clear. That's a 7. There you go. To the 6 minus 1. Close up parentheses. 0.07 underneath. An extra 1.07 in the back. And just like we saw in those sinking fund examples in the previous video, all of this stuff, as spooky as it may look, we can crank it all out, and we just have a number times R. And to get R by itself, we divide by that number. So, as I said in the last video, I'm not actually rounding this off anywhere. Like I said, I keep all of my decimal places of accuracy until I absolutely have to round. So I'm going to call it a twiddly equal because, again, I'm writing a decimal approximation here, but I just left it in exactly in my calculator. So we have 30,000, and when I work out all of this stuff over here, even with the extra 1.07 on the end, I got 7.65402 and some more stuff. I'm just cutting it off there because I don't want to writing lots of stuff on the board is a pain. The calculator had it all in there, and I come up with my regular payments of $3,919.51. So it's again, this is on an annual scale, so that's a big number, but you're already kind of making once a year investments. So, all right, so that's annuities due. That's essentially the difference between what we were doing previously with ordinary annuities is this extra round of interest and this extra 1 plus I sitting at the end of the formula. All right. So the final example on the notes file, again, talks about using Excel. Just like I mentioned previously, there's going to be one video. I'm actually going to take stuff related to Excel from all of our remaining sections of material and do it at once, because the formatting is quite similar for all of them, so I think it's just a better use of recording time rather than me posting a whole bunch of, like I said, 3 or 4 minute videos of here's how this thing works. So look for that eventually. Again, you can tackle most of our stuff just using these formulas and cranking them out by hand. So we'll move on next time to still talking about annuities with a bit of a twist. What if instead of putting money away, we've got a big lump sum that we're drawing money out of? So stay tuned.